In this video, I will be introducing quantum numbers. So, there are four basic quantum numbers, and they're represented with number 1 is N, 2 is L, 3 is M sub L, and the fourth one is M sub S. I'll talk about each of them separately. So the first quantum number is the principal quantum number, which is represented with the letter N. And it defines the relative energy of the orbital. So energy of orbital, as well as the distance from the nucleus. So the smaller the n, let's say n1, is the closest is going to be to the nucleus of the atom. So this will be n1, this will be n2, and so on. So as it grows, it gets further away. And the last thing you should know about the principal quantum number is that it is a positive integer, so it has to be positive. So it can be n equals 1, 2, 3, 4, and so on. But not like n equals -1 or 1/2. Before I introduce the second quantum number, if you have two orbitals with the same n, they will occupy the same principal electron shell. So same n means the same principal electronic shell. This fixes electronic. So same n means same shell. Remember that. Now the second quantum number is called the orbital-angular momentum quantum number. So quantum number. And you represent it with the letter L. So just an L. And this quantum number introduces something called a subshell. So subshell, instead of a shell that just requires the n to be the same, a subshell requires the n and the L to be the same. So the n of the orbital has to be the same, and the L has to be the same. So for orbitals, and there are four subshells depending on the second quantum number. So depending on the value of L, we can have four different subshells. So I'll make a table for it. If the L value is 0, then that subshell is called the S subshell. If the L value is 1, the subshell is P. If the L value is 2, the subshell is D, and if the L value is 3, the subshell is F. And this will be more important when you're writing electron configurations later on. And one last thing for this quantum number is that its maximum value is going to be L max n minus 1. So you're going to have a principal quantum number of 2 and an L of 2. Its maximum value has has to be 1. So L could be 1 or less. And that is the second quantum number. Now let's talk about the third one. That is the magnetic quantum number. And it is represented with an M sub L. M sub L. And what it does is it describes the orientation of the orbital in space. So, orientation of the orbital. And the number of ML values of our third magnetic of our third quantum number will be equal to 2 times L plus 1. That's not a 1. So let's say if we have an L of 1, the number of ML will be 3. So that's just the number. What this represents is that it will be from -1 to 1, going through 0. So it has this equation right here will just tell you how many numbers you have. We have three numbers here, but it doesn't give you the values of them. You will always want to start with writing the 0, and then if this is not 1, because it's a 3, you want to go to the following number, which is 1, and always write the negative of that one. So now we have 3, and that's equal to this. So let's say if L was equal to 3, then our ML will be 7. So we will have 7 numbers in our magnetic quantum number. We start with a 0, then a 1, we write the negative, we have 3 now. Then we go to 2, we write the negative 2, now we have 5, and finally we write 3, and the negative 3. So now we have 7 numbers for our ML. So you have to remember that this number represents just how many numbers you will have here. And finally, the last quantum number, I keep writing in blue, 4, is called the spin quantum number. And it is represented with an M and a sub S because of spin. And it basically just tells you the spin of the electron. So it can be a positive 1/2 or a negative 1/2. In which, if when it's positive, the electron, let's say this is our electron, it will spin in this direction. If it's negative, it will spin in the opposite direction. So this way. So when it's positive, it's counterclockwise. And when it's negative, it's clockwise. This quantum number is usually not used when you write your configurations, so the first 3 are the most important ones. And well, I'll be talking about each of the subshells in the following video. If you found it helpful, like it and make sure to share it with your friends.